Hey guys, welcome back. Today's topic is carbon dioxide and heat are released during respiration. Let's begin with this. Here, carbon dioxide is evolved during respiration. Okay, so this activity let's discuss. So, here take a handful of moong or Bengal gram seeds. Soak the seeds in water a day before. Okay, and keep these soaked seeds in a cloth pouch and tie with a string tightly. Okay, so these are the steps that we need to perform before doing this activity. So here we have to take a handful of moong or Bengal gram seeds, then soak the seeds in water a day before, one day before the activity. Okay, and keep these soaked seeds in a cloth pouch and tie with a string tightly. Okay, after doing this, keep the cloth pouch, okay, here in a corner. Keep the cloth pouch in a corner of classroom. Okay, so this is what we need to do. Now next day, collect the sprouts. So inside this cloth pouch, these seeds will germinate and the sprouts will be resulted. Okay, so these sprouts are germinated seeds. Okay, so here what we need to do is, okay, collect the sprouts or germinated seeds from this cloth pouch and keep it in a glass bottle. Okay, so here around 250 ml glass bottle like this, a glass bottle can be taken and in that it can be kept. Okay, take a small beaker, fill 3/4 of the beaker volume with lime water. What is this lime water? It is nothing but, it is a common name for dilute aqueous solution of calcium hydroxide. Okay, so this dilute aqueous solution of calcium hydroxide is commonly called lime water. Okay, so lime water is a common name for dilute aqueous solution of calcium hydroxide. It is basic. It is basic with pH 12.4. Okay, so this is a pH value for this calcium hydroxide dilute solution. Okay, so what we need to do is take a small beaker, fill 3/4 of the beaker with lime water. You can see here in this picture, this is a small beaker. Okay, 3/4 of the beaker should be filled with lime water. Okay, now after this, keep it in the beaker carefully. Okay, and close the plastic bottle tightly. So like this, this beaker is kept inside the plastic bottle and it is kept, this mouth is closed tightly. Okay, so this is how the apparatus must be arranged. Okay, here the lime water, which is nothing but the dilute aqueous solution of calcium hydroxide, is inside a beaker, a small beaker which is kept inside the plastic bottle and it is closed tightly. Now what happens? What is the purpose of closing that tightly? So that air, okay, from outside, okay, air from outside the bottle should not enter into, okay, the bottle. Okay, that is the objective. So it is closed tightly so that external air will not, here if it is closed, external air will not enter into the bottle. so that whatever air, whatever gases are released during the process of respiration, they are collected here, but not the external air is entering inside. The purpose of closing the plastic bottle is to prevent the entry of external gas to enter inside the plastic bottle. Okay, now it is arranged like this. Okay, after this, make a similar setup with unsprouted seeds. Here, this setup, let's assume this is setup number 1, and here sprouted or germinated seeds are used. Okay, in another setup of these, okay, plastic bottle, beaker, and seeds. Okay, in that we should take the normal seeds, not the germinated seeds or not the sprouted seeds. Okay, so what is to be done? Make a similar set with unsprouted seeds. Okay, now keep this set undisturbed for 1 or 2 days. Okay, so we should not disturb this setup for 1 to 2 days. Okay, so 1 to 2 days we should not disturb. Do not disturb, okay, the setup. Okay, so it will be in the school laboratory. Okay, it is not disturbed. Now during this 1 or 2 days duration, what will happen? Here we find the germinating seeds. So obviously they perform respiration process, and during that respiration process, what is the gaseous product formed? That is carbon dioxide. Okay, so it is collected here. Okay, so that is what happens if it is kept undisturbed for 1 or 2 days. Okay, during this time, observe the color of lime water in both the sets. Okay, so in one of the sets, sprouted seeds are placed. In another set, unsprouted seeds are placed. Now during this 1 or 2 days duration, what we need to do is observe. We need to observe the color change inside. Okay, so here we should find out the color change. Okay, here what color change occurs? This is very important. In which set does the color change occurs? Okay, in set number 1, okay, sprouted seeds are used. In set number 2, unsprouted, okay, unsprouted seeds are used. Obviously, okay, in sprouted seeds condition, they respire and they release, okay, carbon dioxide. Okay, release carbon dioxide. Okay, this is the product of aerobic respiration that is performed by the sprouted seeds. Okay, so this carbon dioxide, okay, what it will do, yeah, when it reacts with this lime water, okay, it is changing into milky white. Okay, so the color changes, it changes to precipitate. Okay, calcium carbonate precipitate is formed, and because of the formation of that precipitate, the milky white, okay, precipitate is seen in setup number 1, where the sprouted seeds are used. Okay, but in another set, okay, where unsprouted seeds are used, carbon dioxide is not released. Okay, and as a result, no color change is observed here. Okay, so what is your answer? In which set does the color change is faster? Okay, so obviously if there are sprouted seeds, the color change is faster, and here it will be very slow process. Okay, here as germination process is taking place, the rate of respiration is comparatively very faster, okay, when compared with this unsprouted seeds. And here the color change will be very, very slow. Okay, so this is about the activity, okay, that describes about CO2 is evolved during respiration. Okay, so here if we check the chemical equation, okay, so here glucose is oxidized, C6H12O6 plus 6O2. Okay, So here it is a 6 CO2 plus 6 H2O plus energy, that is heat energy. So this is a chemical equation. So here what is happening? Carbon dioxide is released, and that carbon dioxide reacts with lime water to form a milky white precipitate. Okay, so this is about the activity carbon dioxide is released during respiration. Okay, and one more, you can see here the energy is also released during this process. And let's check the one more activity, that is heat is evolved during respiration. Okay, take sprouts in a thermos flask. Okay, you can see here this is a thermos flask. Now here sprouts are taken. Okay, so these are the germinating seeds are sprouted seeds. Okay, so like this the sprouted seeds are taken in a thermos flask. Okay, this is a thermos flask. Now what needs to be done here? After this, remove the lid and prepare a cork. Okay, you can see here the picture, this is a cork. Okay, prepared and inserted. Okay, so here remove the lid of the thermos flask and prepare a cork with thermocol or rubber or any other material we can use. Most preferably we can use a rubber cork or thermocol cork. And after removing the lid, we need to place that cork here. So here the lid is removed of the thermos flask and the cork is inserted here. Okay, now what needs to be done here? Through which you can bore a hole to insert a thermometer. After that, through this cork a thermometer is inserted. Okay, in this manner you can see here this is a thermometer. What is the purpose of using thermometer? Here the temperature changes can be noticed. That is the main objective. So thermometer is inserted through the cork into here this thermos flask, inside which the sprouted seeds are placed. Okay, now after this, here take care that one very important aspect is take care that, okay, the bulb of thermometer, okay, the bulb of thermometer should dip in the sprouts. Okay, so this precaution is needed. This is one important precaution while performing this activity. Okay, so take care that the bulb of thermometer should dip in sprout. If you check this figure, you can see this is the bulb of the thermometer and it is dipped in the sprouted seeds. You can see this is the level of the sprouted seeds. All these are the sprouted seeds and the bulb of the thermometer is dipped inside. Okay, so this is how the apparatus is arranged. Now moving to the next, here close the flask with this tight fitting cork. Okay, and record the temperature for every 2 hours. After every 2 hours we need to record the temperature. Okay, recording the temperature. Okay, after every 2 hours. Okay, after every 2 hours we need to record the temperature. Let's suppose, okay, so now let's suppose the activity started at 10 a.m. okay, then what is the temperature? 1. Then after that 12 o'clock. Okay, so what is the temperature? Then after that 2 p.m. okay, what is the temperature? Okay, so like this, after every 2 hours duration we need to record the temperature. Okay, then you are advised to do this for at least 24 hours. So this activity can be performed for about 24 hours. Okay, make a graph by using observations. We can make graph by using observation, and we see that, okay, as the rate of respiration, as the rate of respiration is increasing by the germinating seeds, obviously, okay, the temperature rise will be seen in the graph. Okay, so here this is what we need to remember, that during the process of respiration, heat energy is released, and because of this heat energy released, the temperature rise can be seen in this thermometer. Okay, so we can notice the rise in the temperature, and with this we can conclude that heat energy is evolved during respiration process. Okay, so these are the activities which say about carbon dioxide and heat energy are released during the respiration process. Okay, this is all about today's session. If you are new to my session, subscribe. Okay, if you liked it, share it with your friends. Okay, I'll be back with more videos.